A middlebox, a network appliance, is a computer networking device that transforms, inspects, filters, or otherwise manipulates traffic for purposes other than packet forwarding. Common examples of middleboxes include firewalls, which filter unwanted and malicious traffic, and network address translators, which modify packets' source and destination addresses. Dedicated middlebox hardware is widely deployed in enterprise networks to improve network security and performance. However, even home network routers often have integrated firewall, NAT, or other middlebox functionality. The widespread deployment of middleboxes and other network appliances has resulted in some challenges and criticism due to poor interaction with higher layer protocols. Lixia Zhang, the Jonathan B. Postel Professor of Computer Science at the University of California, Los Angeles, coined the term middlebox in 1999. Types of middleboxes. The following are examples of commonly deployed middleboxes. Firewalls filter traffic based on a set of predefined security rules defined by a network administrator. IP firewalls reject packets based purely on fields in the IP and transport headers, e.g., disallow incoming traffic to certain port numbers, disallow any traffic to certain subnets, etc. Other types of firewalls may use more complex rule sets, including those that inspect traffic at the session or application layer. Intrusion detection systems monitor traffic and collect data for offline analysis for security anomalies. Because IDSs, unlike firewalls, do not filter packets in real time, they traditionally are capable of more complex inspection than firewalls, which must make an accept-reject decision about each packet as it arrives. Network address translators replace the source and/or destination IP addresses of packets that traverse them. Typically, NATs are deployed to allow multiple end hosts to share a single IP address. Hosts behind the NAT are assigned a private IP address and their packets destined to the public Internet traverse a NAT which replaces their internal private address with a shared public address. One optimizes improved bandwidth consumption and perceived latency between dedicated endpoints, typically deployed in large enterprises. One optimizers are deployed near both sending and receiving endpoints of communication. The devices then coordinate to cache and compress traffic that traverses the Internet. Load balancers provide one point of entry to a service, but forward traffic flows to one or more hosts that actually provide the service. Criticism and challenges. Although widely deployed, middleboxes have generated some technical challenges for application development and some controversy regarding their impact. Application interference. Some middleboxes interfere with application functionality, restricting or preventing end-host applications from performing properly. Network address translators present a challenge in that NAT devices divide traffic destined to a public IP address across several receivers. When connections between a host on the Internet and a host behind the NAT are initiated by the host behind the NAT learns that traffic for that connection belongs to the local host. Thus, when traffic coming from the Internet is destined to the public shared address on a particular port, the NAT can direct the traffic to the appropriate host. However, connections initiated by a host on the Internet do not present the NAT any opportunity to learn which internal host the connection belongs to. Moreover, the internal host itself may not even know its own public IP address to announce to potential clients what address to connect to. To resolve this issue, several new protocols have been proposed. Other common middlebox-induced application challenges include web proxies serving stale or out-of-date content, and firewalls rejecting traffic on desired ports. Internet extensibility and design. One criticism of middleboxes is they can limit choice of transport protocols, thus placing limits on application or service designs. Middleboxes may filter or drop traffic that does not conform to expected behaviors. So new or uncommon protocols or protocol extensions may be filtered by middleboxes. Conversely, certain types of middlebox can assist in protocol deployment by providing a translation between new and old protocols. IPv6, for example, can be deployed on public endpoints such as load balancers, proxies, or other forms of NAT, with back-end traffic routed over IPv4 or IPv6. More generally, middleboxes are considered to violate the end-to-end principle of computer system design. See also: firewall, networking, network address translation, end-to-end connectivity, interactive connectivity establishment, ICE, session traversal utilities for NAT, stun, traversal using relay NAT, turn, multi-layer switch.